August 2015, Geometry Common Core Regents Exam, Part 4. Answer the 2 questions in this part. Each correct answer will receive 6 credits. Clearly indicate the necessary steps, including appropriate formula substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. All answers should be written in pen except for graphs and drawings, which should be done in pencil. This is for a total of 12 points. Number 35. In the diagram of parallelogram ABCD below, BE is perpendicular to line CED, and DF is perpendicular to line BFC, and CE is congruent to CF. Prove ABCD is a rhombus. So in order to prove something a rhombus, I need to show all 4 sides as congruent. So the first thing that I'm going to do is designate the information that was in the given, which is up here. So BE is perpendicular to CD, CED that is. I'm going to start with my statements. So I can follow up with my reasons. So all the given information, including that we have a parallelogram ABCD, has now been denoted in the picture. I'm going to also, in the diagram, denote the given information, which is that we have right angles there, and 2 congruent sides. So since we have right angles, I'm going to say that we have them. So angle CFD is congruent to angle CEB, because perpendicular lines form right angles and they are congruent. So my next step is to prove that well, it's not my next step, it's my second to next step. I want to prove that the triangles CEB as well as CFD are congruent, so then I could use corresponding parts of congruent triangles congruent to show that the 2 sides of the parallelogram are congruent. So I need to have one more piece of information to be able to prove the triangles congruent. And that piece of information is that angle C is congruent to itself. And the reason as to why is the reflexive property. So now I have the 2 triangles congruent. By means of angle side angle, and now I can say that BC is congruent to DC by means of CPCTC, which stands for C corresponding parts of congruent triangles are congruent. And for the sixth and final step, I can make the conclusion that ABCD is, in fact, a rhombus. Because I've been able to use CPC2C to show that these two sides, the entire length of BC as well as DC, are congruent. And in a parallelogram, opposite sides are also congruent, so that makes all four sides congruent. So again, ABCD is a rhombus because it is a parallelogram. With four congruent sides. Number 36. Walter wants to make 100 candles in the shape of a cone for his new candle business. The molds shown below will be used to make the candles. Each mold will have a height of 8 inches and a diameter of 3 inches. When I see diameter, typically I just write what the radius is. I may or may not need to use it, but I just go ahead and write it just to make sure that I at least have thought about it. To the nearest cubic inch, what will be the total volume of 100 candles? Okay, so volume for a cone is equal to 1/3 the area of the base, which is pi r squared, it's a circle in this case, times h. We're going to take 1/3 pi times 1.5, and the h here is the same thing as this outside part we assigned to be 8, so it's times 8. Okay, so 1/3 pi times 1.5 squared times 8, the height, gives us a volume for one cone to be 18.85, and now we need to find for 100 cones, so we multiply that by 100 and get 1885, and that is cubic inches. So now the next part says, Walter goes to a hobby store to buy the wax for his candles. The wax costs 10 cents per ounce. If the weight of the wax is 0.52 ounce per cubic inch, how much will it cost Walter to buy the wax for 100 candles? So we're going to take the volume, 1885 cubic inches, and multiply that to the weight of the wax, which is 0.52 ounces per cubic inch, and we're also going to multiply that to the 10 cents per ounce. And as a result, I can get rid of the cubic inches and the ounces and get 9802. Now the next part states that if Walter spent a total of $37.83 for the molds and charges $1.95 for each candle, what is Walter's profit after selling 100 candles? So we're going to multiply $1.95 to 100 candles, which is the revenue that they would be taking in. However, we need to subtract the total costs here. Money laid out, $37.83 and $98.02, which will leave us a profit of $59.15.